Let's construct a tree diagram now from the following example. The following example has two fair coins tossed. That means that they're not biased, so the probability of a heads or the probability of a tails is 1/2. We're going to create a sample space and then make a tree diagram where we can observe no heads or more than one tail or any specific outcome. Remember, the sample space that talks all about all possible outcomes. So my sample space will be that I could have, from the first coin, I could have, let's call it coin 1, heads or tails. And from then the second one, I could have heads or tails. Which means the possible outcomes are heads followed by heads, heads followed by tails, tails followed by heads, or tails followed by tails. And that is my sample space. So I'm going to put a box around that so the examiner or the teacher knows that that's my answer. The next thing I'm going to do is construct my tree diagram. And remember, when I construct a tree diagram, I want to have everything in order. And then I want to also remember that each branch represents an outcome. So if I'm going to construct this tree diagram, and I'll do it in the middle, I start off with my first toss of the coin, and I can have heads or tails. Then I toss my second coin. Let's do that in a different color. And I get a head or a tail, or a head or a tail. And that's how the tree diagram is going to look for tossing the coin. Now what I'll do is I'll put my probabilities in. And for probability, it's always good to remember fractions are always the greatest way to do probability. So I'm going to write here, fractions are your friend. Isn't that lovely? So let's create our tree diagram using our fractions. So the chance of a heads there is 1/2 and tails is 1/2. That's with the first coin. And with the second coin, they're halves as well. Now let's answer the questions now that we've got that there. The first question says the probability of having no heads, that is the same as the probability of tails followed by tails, which is, let's follow the green path. That means I come down here to tails, and then I keep going down here to tails. So my probabilities there is 1/2 times 1/2, and that equals 1/4. And I'm going to put that in a box again because that's good technique. My second question asks me, what is the probability of more than one tail? Now we need to remember that when it says more than one tail, that does not include one tail. So this actually means heads followed by heads. Sorry, tails followed by tails. There is no other way I can manage this. So there's tails followed by tails. That means I'm again following exactly the same path. So once again, I'm looking at tails followed by tails, and that's 1/4. If it asked for at least one tail, so let's have a look at that as an example that I'll throw in just for good measure. So C, at least one tail. Then what we would have to look at, and let's go to some, what's another color I haven't used? Let's look at red. At least one tail would mean I can follow this red path, heads and then a tail. There's one tail. I can follow this red path, tail to heads, and I can also follow tail to tail. So there would be 3 possible outcomes. Now, at least one tail, I would write as the probability that tail is greater than or equal to 1. So there is at least one. And each of these steps, each of these branches follow 1/2 times 1/2. So this would be 1/4. this would be 1/4, and we've already established that 2 tails is 1/4. So it would be 1/4 plus 1/4 plus 1/4, which equals 3/4. So that's the probability that we have at least one tail. Wasn't asked in the example, but it's always good to be able to manage our tree diagrams for slightly more tricky outcomes.
If you found this video helpful, please subscribe or like. Thanks.